So we're back with another examination, O-level chemistry, paper 1, and we're going to be doing October-November paper 1, 2, which is variant 2. I picked this one particularly because it had a lower threshold, and now lower threshold means sometimes it means harder questions, and that's why perhaps the threshold was lower. So let's see why the questions were harder, and let's see if we could do those. So let's begin. Question 1 says, the concentration of aqueous sodium carbonate can be found by reaction with hydrochloric acid of known concentration. The indicator methyl orange is used. We know indicator is being used, which means it's a titration. Sodium carbonate is a soluble substance, even though it's a carbonate, but it is soluble and it's reacting with hydrochloric acid, which is again aqueous. Which items of equipment are needed? We definitely, before looking at the options, we know we need a burette. We're going to need a pipette, and perhaps we're going to need a conical flask. Option 1 includes a gas syringe, and there is no need to collect a gas. We are not concerned with the rate of reaction. Option B is concerned with thermometer, but it does not mention anything about a pipette. And a pipette is a really good, accurate piece of apparatus which we are going to be needing. So option B is also incorrect. Option C makes a lot sense because it is involving burette and pipette, which are both very vital in titrations. Option D has stopwatch. We don't need to measure the rate of reaction. So C for cat is the answer. The diagram shows 3 stages, 1, 2 and 3 used in the preparation of a salt. Spatula, there's reactants, then there's residue which shows some kind of filtration over here. And then you're collecting a salt, and then perhaps you're heating it, and then you're collecting the filtrate, and then it seems like you are crystallizing it. Which row correctly shows the solubilities of both the reactants and of the salt formed in this preparation? When you look at the solubility of the reactants, it looks like this one was insoluble, because if you remember, the second method which we generally use involves insoluble metal oxides or metal carbonates. Maybe that is why you are doing the filtration. If you do filtration to remove excess insoluble reactants. For example, if you were using iron oxide or iron carbonate, zinc oxide, zinc carbonate, copper oxide, copper carbonate, these are insoluble reactants, and this is definitely a soluble reactant because it is here in the beginning. So you had one soluble reactant, the other was insoluble reactant, and then finally your salt seems to be soluble because you are collecting it by crystallization. You do crystallization only for the soluble salts. So apparently the salt is soluble, but the solubility of the reactants was soluble and insoluble. So I believe D for doctor is the right answer. The nucleon number of an atom is typically greater than its proton number. Obviously because it has neutrons, right? That is why nucleons are always more than protons. The difference between these two numbers indicates the number of dash in the atom. So the number atomic mass minus atomic number indicates the number of neutrons. So blank number 1 should be neutrons. Atoms that have different nucleon numbers but the same proton number are called isotopes. They're isotopes because they have the same proton number. So it's going to be number of neutrons and then isotopes. So I believe 3 has to be D for doctor again. Which 3 elements exist as diatomic molecules at room temperature? Hydrogen does, oxygen does, helium does not. Again, neon does not. In option C, I think nitrogen, oxygen and fluorine all are gases at room temperature and they are diatomic. Over here, helium again, wrong. So C for cat. Let's go for question 5. Which is a pure compound? Dry air is a mixture of gases. Ethanol is a pure compound. It has a chemical formula C2H5OH, or you can say C2H6O. Steel is an alloy. It's a mixture of iron, carbon and sometimes chromium. Petrol again is a crude oil mixture. It's again a mixture. So pure compound is B for Barrows. Which diagram best represents the structure of a solid metal, which means a metallic lattice? Now, obviously, your first thought is going to be like A is definitely not the answer, because why does it have negative ions? Metals don't have negative ions. They have positive ions surrounded by a sea of electron. Now we need to see it is not this. Again, C is not the answer, because here the negative ions are very much arranged in a regular pattern. So why are the electrons arranged in a regular pattern? I should be using the word of mobile electrons. Why are the mobile electrons arranged so systematically? As far as I remember, they are always in a motion. They're always making a sea or a cloud, you know. So it can't be C for cat either. Now B or D. I am concerned a little because in option D you can see the positive ions are touching each other, but positive ions repel each other, and that is why they can't be touching each other. So D is again wrong. The answer has to be B for Barrows again, because the positive ions repel. There has to be some gap between them. This gap is not for allowing room for the electron movement. No, electrons don't need room for the movement. They are very small. They can move on their own. They don't need spaces. It's all about the repulsion between the positive ions, which is why the positive ions have slight spaces between them. So guys, let's continue with question 7. It says hydrogen sulfide burns in excess of oxygen according to the equation shown. 48 decimeter cube of hydrogen sulfide is burned. Now this is the volume of hydrogen sulfide. Okay. Now remember one thing. They're concerned with which volume of sulfur dioxide will be formed. So it's a relationship between hydrogen sulfide and sulfur dioxide. If you have watched my video on mole hack, you would remember that the mole ratios are actually equal to the volumetric ratio. Now, if hydrogen sulfide and sulfur dioxide are being compared, 48 decimeter cube of one is equal to how much volume of the other, but their mole ratio is 2:2, which means technically 1:1. So it's going to give you the same volume. So it's going to give you 48 decimeter cube. So that is the answer. Which statement about electrical conductivity is correct? Covalent compounds such as glucose conduct when molten or dissolved in water. No, sorry. Covalent compounds never conduct. Dilute acids such as sulfuric acid conduct because all the ions are free to move. Yeah, that is true, because sulfuric acid or other acids have H plus ions, and anions like chloride or like, for example, nitrate, depending on nitric acid or whatever. So yeah, they do have ions. Ionic compounds such as sodium chloride conduct due to the movement of electrons. No, sorry. They conduct by the movement of mobile ions like the cations and the anions. Metals such as copper conduct due to the movement of positive ions. Never. Metals conduct by the movement of mobile sea of electrons. So B for Barrows is the answer. I'm really happy because a lot of options are B over here and I get to see my name again and again. Ammonia is manufactured from nitrogen and hydrogen by the Haber process. What is the percentage yield when 60 kg of ammonia is produced from 60 kg of hydrogen? Now you have the reactant in front of you and you have the actual yield in front of you. So this is the actual yield, or you can say actual product in front of you, and this is the reactant. When the question is concerned with percentage yield, you remember the formula as percentage yield is equals to actual divided by theoretical times 100. You do have the actual yield in front of you, but you don't have the theoretical one. So how do you find that? There's a simple formula for that. You can compare hydrogen and ammonia in terms of their molar ratio. The formula is mass over mRn is equals to mass over mRn. The mass for hydrogen is 60 kg. The mR of hydrogen is 2. The mole ratio in the equation for hydrogen is 3. For ammonia, you don't know the mass. You're going to calculate that. The mR of ammonia is 17 units and the mole ratio for ammonia is 2 units. So you're going to cancel the 2 from left side with the right side. This 60 divided by 3 becomes 20. And then this 17 goes over here. So 20 times 17 becomes 340, which is the mass of ammonia. Now you can find that. You're going to be like, okay, we were supposed to be getting 340, which was the theoretical yield, but we are getting only 60 times 100. So you can just simply solve it. It's going to be 600 divided by 34, and you're going to be like, okay, let me do it. It's going to be 600 divided by 34, which is 17.64%. For me, that is 17.64%. Where do we have it? In option B. So 9 is B for Barrows again. What is the ratio of the number of molecules in 71 gram chlorine? 71 gram gaseous chlorine is 1 mole. But you're going to be like, sir, isn't the molecular mass of chlorine 35.5? No. 35.5 is 1 chlorine's atomic mass. Chlorine means Cl2. To the number of molecules in 2 gram gaseous hydrogen. That is again 1 mole. So it's going to be like 1:1 ratio because both have 1 mole. For hydrogen, the MR is 2. For chlorine, the MR is 71. So 10 is going to be A. The diagram shows the apparatus for an electrolysis experiment. Using the apparatus shown, which electrolyte would give colorless gases at both electrodes? If you were doing copper sulfate, you would be getting copper at cathode because copper is lower than hydrogen in the reactivity series. So if it's aqueous copper, even though hydrogen ions are here, you would be getting copper at cathode, so not a colorless gas. Concentrated aqueous sodium chloride, it is going to give you hydrogen gas at cathode and chlorine gas at anode. Chlorine is not colorless, so it's still not colorless gases. Dilute sulfuric acid, definitely, because in dilute sulfuric acid you're going to get hydrogen gas at cathode and you're going to get oxygen gas at the anode. Sulfate from the sulfuric acid will never discharge, so C for cat is the answer. Molten lead bromide is going to give you lead at cathode and it's going to give you bromine Br2 at the anode. So C for cat is the answer. Which metal is most likely to be extracted from its molten chloride by the use of electrolysis? So which metal do we go for if we're going to be using electrolysis? Electrolysis generally goes for very reactive metal, so very higher in series. So it's going to be silver. Silver can be extracted really easily. Copper can be extracted really easily. Same for iron. Calcium is very high in the series. Calcium is extracted only by the electrolytic method. Let's go for question 13. Two energy profile diagrams are shown. The scale on the y-axis is the same for both diagrams. Which statement is correct? Both reactions are exothermic. No, sorry. This reaction is apparently very slightly endothermic. This reaction is largely endothermic, but both are endothermic reactions. Only one reaction is endothermic. Again, wrong. Both reactions are endothermic. The activation energy of reaction 1 is smaller than the activation energy for reaction 2. Now let me show you. The activation energy of reaction 1 is really high, and for reaction 2 it's smaller. So activation energy of reaction number 1 is higher. That is wrong. It's not smaller. The enthalpy change of reaction 2 is larger. We did see that enthalpy change of reaction 1 is larger than the enthalpy change of reaction 1. Enthalpy change for reaction 2 is higher. You can see it from the arrows. For reaction 2 it's really bigger. That is why D for doctor is the answer. Ammonium nitrate dissolves in water. Ammonium nitrate is this one. It dissolves in water. The enthalpy change is positive, which means it's an endothermic reaction. It absorbs heat. Which statements are correct? The reaction is endothermic. Yes, that is true because of the positive enthalpy. Positive enthalpy. The water gets colder during the reaction. Yeah, that is again true because endothermic reactions absorb heat, and when they absorb heat, the environment or the solution or the system becomes colder. Heat energy is absorbed by the ammonium nitrate from the water. So when ammonium nitrate is being dissolved, obviously it's going to be dissolving itself while absorbing heat from the surrounding environment, and the surrounding environment is water. So it's going to be absorbing the heat from the water because it's endothermic. So it's going to be D for doctor. 1, 2, and 3. Which statement about photosynthesis is correct? Chlorophyll is a reactant. No, sorry. Chlorophyll is just a pigment that allows the reaction to complete. It has those biological enzymes which help in the reaction to complete. Oxygen is a product, yes. If you remember, chlorophyll is a reactant, and what happens actually is that 6 moles carbon dioxide react with 6 moles of water. That is a net equation actually, that is not the correct equation, but you will find that in the textbook. And then it gives you 1 mole of glucose, which is C6H12O6, and you get 6 moles of oxygen gas. So oxygen is actually a product. Sunlight is a reactor. No, sorry. Sunlight is a source of energy. It's a source of energy, much like heat. Water is a product. No, sorry. Water is not actually a product. The product is going to be product is going to be oxygen gas. So oxygen gas is a product. So we're going to be like, okay, B for Burroughs again. In which reaction is the underlying substance reduced? Now that is interesting. When you see option A, carbon has an oxidation number of 0 because it's a single element. Single elements are always having oxidation number 0. And when it is going with oxygen, it is actually making itself +2 because oxygen is equals to -2. For carbon monoxide, oxygen is -2 and carbon has to be +2. So carbon is changing from 0 to +2. It is a kind of oxidation. When you look at chlorine, chlorine is again 0 because it's a single element. When you look at the equation, it is becoming -1. So chlorine was 0, but then it's becoming chloride ion, which has an oxidation number of -1. So it's a kind of decrease, which means reduction. So my vote is going for option B because it is indeed reduction. Magnesium has an oxidation number of 0, but when it's becoming a part of magnesium oxide, the oxygen is -2 and magnesium is +2. So magnesium is becoming +2. Again, that is a kind of oxidation. If you look at zinc, zinc is going to be like 0 in the beginning and then it's becoming +2. So that is again a kind of oxidation. So the answer is going to be like B for Burroughs. Catalysts alter the rate of chemical reactions. Which statements correctly describe the effect of adding a catalyst to a reaction? All reactant particles have more energy. No, sorry. It does not increase the energy, it decreases the activation energy. Increasing energy is only because of the temperature changes. So that is not true. The activation energy is lowered. Yes, that is true. More reactant particles collide with enough energy to react. Yes, since the activation energy has been decreased, it is going to allow more and more particles with enough activation energy because now the threshold has been lowered now. So now more particles have the required activation energy. So 2 and 3. Let's go for question 18. Solution T has the following properties. It reacts with magnesium forming a gas. So if it's reacting with metal and it's making a gas, maybe it's an acid because acids react with metals and give a gas. It could be water, but magnesium reacts with cold water very, very rarely. It reacts with calcium carbonate forming a gas. Again, if it's reacting with calcium carbonate, again acids react to give a gas. This gas could be hydrogen and this gas could be carbon dioxide. Which statement about solution T is correct? It contains more OH ions than H+. Wrong, because if it's an acid, it should have more H+. It has a pH 9. Wrong. Acids have a pH below 7. Its reaction with calcium carbonate produces hydrogen. No, sorry, it produces carbon dioxide. It reacts with aqueous ammonia. Yes, that is true because aqueous ammonia is alkaline and our solution T is acidic. So it does react with aqueous ammonia. Which substance is soluble in water? So calcium carbonate, a basic substance, not soluble in water. Sorry, copper carbonate, not soluble in water. Copper oxide, again a basic substance, not soluble in water. Copper hydroxide is again a blue precipitate. It looks something like this, not soluble in water. All the nitrates are always soluble. All nitrates, anything with a nitrate is always soluble. So copper 2 nitrate is soluble. Which statement about ammonia is correct? Ammonia is an alkaline gas with the chemical formula NH3. It is a colorless and odorless gas. No, sorry, it has a very pungent smell. If you have ever been to a pharmaceutical company or a cosmetic company, oh god, ammonia is really pungent. It is a gas that turns damp blue litmus paper red. No, sorry. It is the other way around because it's a basic gas. It turns red litmus paper into blue. It is formed when potassium nitrate is heated with aqueous sodium hydroxide and aluminium. That is very true. Because in the test of nitrates, when you add alkali and you add a piece of aluminium, that is a test for nitrate, by the way, that is a test for nitrate, you get ammonia gas and then you confirm it by litmus paper. So C is correct. Nitrates, when they react with sodium hydroxide or any alkali and a piece of aluminium foil, it produces ammonia gas. It is manufactured using vanadium oxide. No, sorry. Vanadium 5 oxide is used as a catalyst in sulfuric acid contact process. So that is wrong. So C for cat is the answer. In the next video, we're going to be doing the remaining half of the MCQs from this particular paper. So stay tuned, guys.